Good afternoon, doctor. My name is Luna, and we are Group E. Our group members including me and Liu Qingxun, Wang Yitong, Wang Yashu, and Yin Qiuyu. And today we will present our study on economic risk assessment of bricklayers in the construction industry. So as we all know, construction is a highly labor-intensive industry. Bricklayers in particular are exposed to repetitive tasks and awkward postures daily, like bending, carrying heavy bricks, kneeling, or lifting arms for long hours. So our main purpose is to analyze common bad postures among bricklayers and to identify economic risk on site and also suggest improvements for safer and more efficient work improvements. And we also developed an error form for further analysis. And we refer on-site observations and radio analysis from platforms like YouTube to study real-life bricklaying activities. As for references, we followed the latest DOGE guidelines on ergonomic safety and sitting posture, including the ERA 2024 guidelines. And our process includes 4 key steps. First, collect bricklaying work videos and identify risk factors using reference tables and analyze the body parts involved and posture duration. And last is build a preliminary error table for assessment. So for awkward postures, we identified several high-risk postures based on duration and body positioning that require further economic evaluation. This includes raising the arms above shoulder height for over 2 hours, such as when laying bricks on high wall, and looking down more than 45 degrees or tightening the hand back while checking alignment. And bending the back forward for more than 4 hours when lifting bricks or mixing mortar, kneeling for over 2 hours to lay bricks near the ground, twisting or bending the wrists for more than 30 meters, while spreading mortar and twisting the neck to look sideways or coordinate with the team for extended periods. That's all about the first part, and Yin Qiuyu will introduce the second part. Thank you.
My part will continue to explain the initial ERA. First of all, it's stated that sustainable posture. Players need to engage in 4 actions in these postures. The first is the action of lowering and raising the head while laying bricks. The third is the bending in action, and the fourth is the bending over action while laying bricks. These have been mentioned in the awkward postures table earlier. The second is the action of standing for a long time, which also belongs to a prolonged static posture. The basic duration is usually more than 2 hours. Next page. The second part is about forceful exertion. Firstly, the lifting and lowering section. The first picture shows the recommended raise under different circumstances. Taking the right-hand picture as an example. Gender is male, working height is elbow height. Approximated degree is between further and close. Therefore, it can be calculated that recommended weight is 15 kilograms. The basis for the calculation is an intermediate weight can be chosen if the hands are close to a boundary between boxes. According to the document, the weight of the hollow brick is 4 kilograms. In the picture, the worker moved 2 pieces, so the total weight was 8 kilograms. Because 8 kilograms is less than 15 kilograms, therefore it doesn't exceed the limit. Repeated lifting and lowering section. The relevant regulations are as shown in the table according to the survey. The frequency of the workers twice per minute, So the final weight limit is 10.5 kilograms, not exceed the limit. Next page. Lifting and lowering with twisted body posture section. This part requires further correction based on the results obtained from the previous two parts. As shown in the picture, the bricklayer needs to twist his body to move the bricks from one side to another based on the previous two parts. And this part, the final recommended weight is 6.75 kilograms. According to the data, each ordinary solid brick weighs approximately 2.63 kilograms. The workers were transporting 3 bricks, so the total weight is 7.89 kilograms, which exceeded recommended weight. Pushing and pulling section, the same steps as in the previous part were followed. By observing the actual situation, such as road smooth, and referring to the table, the conclusion was reached that the weight didn't exceed the recommended limit. Next page, please. Carrying section. Generally speaking, for construction sites, the bricklayers working this stage requires the use of advanced ERA because at construction sites, the ground conditions are usually poor and there are many obstacles along the carrying path. Next page, please. The third part is repetitive motion. This part is the same as the first part, static and sustained work posture. The tasks I have listed all require checking yes because they all exceed the time limit. The repetitive task of a bricklayer mainly involve the upper body, meaning including thruster and lifting. That's all my part, and next part will introduced by my teammates watching Xing.
Okay, hello everyone, I'm Luo Qingxun. I will now present our group simulated assessment of vibration and environmental risk factors in bricklaying operations, followed by a summary of the initial ergonomic risk assessment and a discussion of our findings. First, let's look at the vibration risk. Vibration is divided into hand-arm vibration and whole body vibration. Whole body vibration generally not applicable to typical bricklaying tasks, simulated as no. As for hard arm vibration, these are generally two potential sources of vibration that bricklayers may encounter in their work. One is the use of power tools to cut bricks, such as cutting, and the other is the use of small vibrating compaction tools. According to the image and video materials, bricklayers offer Will's PPE when performing cutting operations, but the frequency of use is relatively low. However, during compensation operations, they do not wear PPE and work intact period of time. So score of this item would be 1 point. Okay, next line. Next are the environmental risk factors. We'll start with lighting. Bricklayers mostly work outdoors. As can see from the pictures, there is sufficient light on both sunny and cloudy days, and the work surface is clear. Based on this, it can be concluded that there are no earthquake conditions. The score of this is 0 points. Okay, next. The second environmental risk is extreme temperature. Bricklayers typically work outdoor and are susceptible to extreme temperature. The image shows work sweating profusely under direct sunlight in the hot weather and working in stiff conditions in snowy weather. This can lead to heat stroke, hydration, and other issues. So this item is scoring 1 point. Okay, next is the ventilation. Although bricklaying is commonly performed outdoor, indoor or semi-enclosed environment should not be overlooked, especially since bricklaying generates a large amount of dust. and the indoor ventilation conditions are often poor as shown in the diagram. This item is 1 point. Next, the first is noisy. The construction signs often generate noisy, showing a noisy monetary reaching for 101.2 dB, which was used as the basis for our assessment, as the picture shows. Okay, next. So now we consider all these issues similar assessment result into the Dodge table 3.50. That concludes my part of my presentation. Next, my team member Wang Yashi will discuss the table.
After listening to my teammates' analysis of specific job risks, I will now take a boundary review to discuss the overall engineering risks in our construction environment and share both engineering and administrative strategies for mitigation. Construction workers, especially bricklayers, face significant economic risks. Next. First, awkward postures like constant bleeding or kneeling can damage the lower back, neck, knees, and shoulders. The second, repetitive motions in the waist and arms may lead to carpal tunnel syndrome and tendinitis or footing. Third, forceful extensions such as lifting heavy bricks and cause muscle strain and joint injuries. Fourth, vibrative exposure for may result in nerve damage or hand harm vibration syndrome. Fifth, extreme temperatures can cause heat stroke or coagulation. The last one is dust and poor ventilation threaten respiratory health with the risks like multiplicative and economical boundaries. Next. From an engineering perspective, we recommend optimizing workstation height to reduce bending. Use machinery as like torres or arms for lifting bricks. Applying vibration dampening materials onto handles. Installing dust extraction systems in enclosed areas. Providing temporary shelters to protect workers from extreme weather. Next. Administratively, we should implement job rotation to prevent prolonged postures, conduct economic and safety training regularly, ensure proper use of personal protective equipment (PPE), schedule regular health controls for early detection, maintain long-term exposure record of dust and noise. In conclusion, the health risks in construction are both diverse and cumulative. Only by combating engineering improvements with administrative controls can we truly reduce risks and protect the workforce. Next is my teamwork's Wang Yitong.
Hello everyone, this is my part. I will divide it for 3 parts. The part 1 is about challenges and limitations, lower economic awareness among workers and site supervisors, limited automation and mechanization in bricklaying tasks, difficulty in monitoring and controlling environmental factors and inconsistent use of PPE, lack of real-time economic feedback tools for posture correction. Next page, thank you. And part 2 is about future outlook. I will separate it for 4 parts. The point 1 is about integration of AI-based posture monitoring systems. The point 2 is use of exoskeletons to reduce strain on the body. The point 3 is the development of smart wearable for real-time health tracking. The point 4 is designing modular and ergonomic construction equipment. Next page. And the finally part is about summary and OR optimization. Significant economics risk required structural intervention. We should standardize ERA system enables consistent risk identification and combining engineering controls with administrative measures enhances safety and efficiency. Finally, future improvements should integrate economic design and smart technology. Next page. Our group have finished. Thank you for watching and listening.